Hello everyone, welcome to Learn DAX channel. My name is Siddesh and this is the fifth video in the end-to-end DAX project video series in which we have been given a bunch of business problems which we then are converting into DAX queries. If you haven't watched the first four parts, I really encourage you to go and watch those first four parts before watching this video. I will leave the link of those videos in the description. I will also leave the link of the dataset that we are using for this demonstration and also the DAX queries that we are using in the same Excel sheet. So you can practice along after watching this video or during uh, or while you're watching this video. So without further ado, let's start with this video and let's take a look at what problems we have to solve today. So first problem that we are solving here is we have to calculate sales contribution by each country. So now there are two ways of solving this. But before that, let's just understand what the problem is. So we have the sales table in which we have a country column. And in the country column, I have three countries. So what I'm trying to figure out here is what percentage of the total sales amount, which is 29,765, is being contributed by UK, by US, and by Canada. So in that way, business can know that which country is the best performing country in terms of sales and which country is the least performing in terms of sales. So to do that, there are two ways. The first approach is simply by using a measure. And the second way is by using a calculated table, using a summarize function. So let's start with the easier way first. First of all, I already have the total revenue, but what I want is because I want country-wise revenue, I would need a measure which is going to negate the effect of the filter context being brought in by the country. So what do I mean by that? So let's say I have this sales table and I bring the country onto the canvas and I change it to a table and I pull the total revenue, which is total revenue. Yeah, I pull this total revenue here. So when I pull the total revenue, it is going to filter this 29765 such that when I'm calculating in the context of Canada, it's giving me 8785. When I'm calculating in context of UK, it's giving me 6015. And when I'm calculating in context of USA, it's giving me 14965. Now, in order to negate the effect of this filter context, I have to slightly modify that measure. In order to do that, I'll just use an all function. So I'll quickly create a new measure and I will call it all revenue is equal to calculate sum x, or I can simply use sum also. Sales, sales amount, and to negate the filter context of this, I'm going to use the all function and I'm going to pass in sales as the argument. So what that will do is any filter context coming from any column of the sales table is going to get negated and only going to see this value, which is 29765. I'm only going to see this value in the new measure that I'm going to create. So the moment I pull this here, all I see is 29765. So for the time being, you can ignore this blank row that is showing up. It's not going to affect our calculations. So I said that it is going to negate the effect of the filter context regardless of any column that I pull from the sales table. So let's test it. Let me just create another. Let me pull in some other parameter. Let's say the region. And if I bring the total revenue, is this the total revenue? No. Is this the one? Yeah, this is the one. So again, total revenue has this value 29765, but the moment I bring it in the context of the region, it is modifying itself and adapting itself to the value in the context in which it's called upon. So if it's east, it's adapting itself to show me 3835. If it's north, it's adapting itself to show me 8670. And in order to negate this effect, what did I do? I used an all function and in which I passed the sales table as the argument. So any column coming from the sales table, its filter context effect is going to get negated. So the moment I pull it here, there's only one value that I can see here, and that is 29765. So in order to then calculate the contribution of each country in my total revenue, what I essentially need to do is to divide this total revenue by this all revenue. So I'll quickly create a new measure and I will call it per country contribution, per country contribution is equal to divide, and that will be total revenue, and in the denominator I will have all revenue. And the third argument is, should there be a 0 by 0 situation, what should be the alternate result? I'm just writing 0 in this case. So I pull this here on this table and I change its formatting to show me a percentage, and this is what I get: 29.51, 20.21, and 50.28, which means that USA is the highest performing country in my sales. So now let's use a summarize function to get the same result. In order to do that, I'll just quickly create a new table. I will call it contribution percentage. And by the way, uh, this is the DAX query that has been supplied in the Excel sheet. So you can use this straight away from the Excel. So let's break down what all do we want while calculating the contribution percentage by country. Well, first of all, I am going to source data from the sales table. The second thing is I am going to group by the sales country. So the group by column is going to be sales country. Now the next thing is going to be the calculation of the total revenue. So the column name is going to be total revenue, and the way I calculate is by using the sumx function, in which the first argument will be sales, the second argument is going to be the sales amount, and then the next column has to be, let's say, all revenue. I'm just taking reference of the table that I already have in front of me. All revenue should be, again, calculate sumx sales, sales amount. But then in order to negate the filter context being introduced by any column of the sales table, I am going to pass sales table as the argument in the all function. And now I need another column. I'll call it per country contribution. Why do I see this squiggly line at the bottom? Maybe I missed a comma somewhere. Oh yeah, here. Now that has to be a division of this particular expression and this particular expression. So we are essentially doing the same thing. It's just that we are doing everything in one table, in one go at a time. And the third argument will be 0 again. We'll multiply it by 100. And I think that should be it. Let's see. Let's see what happens. So if I quickly pull the contribution percentage by country table on my canvas and verify my calculations are correct, then this table and this table should be exactly identical. So let's see. So far it is giving me the correct output, and we have verified that the contribution of Canada is 29.51. Canada contribution is 29.51. For UK it's 20.21. For UK it's 20.21. And for USA it's 50.28. So we essentially used two ways to figure out the same solution, except that in the first way, why we were creating measures, singular measures, and then aggregating that value by using the divide function, and then pulling those measures one by one in this particular table and getting the output. Whereas in this case, what we did was the measures that we are creating, we just wrote them in each of our argument in the summarize function. So we essentially did the same thing, except that in case of measure, they were individual entities which can be used in any context. Whereas in this case, we use these particular measures or these particular uh, little calculations or expressions in one function itself to get to the same output. Now let's focus on the second part, which is to calculate the sales contribution by product. Now this is going to be fairly simple because we did something with the country. Now to in order to calculate the same thing for a product, all I'm going to do is just replace this sales country by the product name. So if I copy this, I go to modeling, create a new table, and I paste it here, and instead of country I write here product, and I change this to product name, and total revenue remains the same, all revenue remains the same. I'll call it per product contribution, and I should get probably the same thing. So let me just pull all the columns from the product name. I think I'll need a bigger table for this. I can bring it here. Yeah. So for product, I have around 10 products or 15, I guess. Yeah, 15 products. So first is total revenue, then you have all revenue, then you have per product revenue, per product contribution. Yeah. Now, since we want to also use the other way, which is by using a measure, so let's try that as well. So in that case, I don't have to create any measure. All I've got to do is source the product name from the products table. So we do that here. Then I need to get, let me bring this here, make some space for this. Or I can just simply copy these two tables and paste it in another page for the time being. Yeah. And I need the measure, which is the total revenue. Total revenue. So the total revenue measure is going to, it is going to respect the filter context being introduced by each product and give me the values accordingly. And then I need a measure which ignores this filter context introduced by the product name, which should be my all revenue measure, which is going to ignore this filter context. And then I need a divide function, which I already have per country contribution. I would rather say per entity contribution because it can change based on whatever selection we make. It could be product name, it could be region, it could be country, it could be a product category. And when I check these two tables, again, I can see that they are identical to each other. So Bluetooth speaker has a contribution of 1.08%, and so do I see in the calculated table. The product contributions in sales for desktop PC is 3.83% here and 3.83% in my calculated table, which I created using a measure as well. So in these two examples, we have covered how can we solve the same problem using either a measure or by using a table, essentially, like using a measure or by using a table. So now let's move on to the last bit of this video, which is to calculate the total cost of goods sold. Now the measure for this particular problem statement is going to be very easy. But the tricky part here is what is it that you're going to aggregate? So if I go to the sales table, and if you say the total cost of goods sold is the total cost price, or is it going to be the unit price? Well, it is going to be the cost price times the quantity because cost of goods sold is not the cost price of the product. Cost of goods sold is the cost price times the quantity. The profit that we are going to calculate is going to be based on the selling price and the discount. So if you created a product and the cost of creating it or the cost price is 100 and the quantity that you sold was 2, so gives me the cost of goods sold to be 200. And if you are selling it at 120 and then you are giving a discount of certain 15% and then getting the gross profit, so the gross profit is going to be measured on the cost of goods sold. And so in this context, the cost of goods sold is going to be cost price into the quantity. So I will quickly create a new measure. I will call it cost of goods sold, or I'll just call it COGS, total COGS, is equal to calculate um, sum x sales, and I will have to multiply the quantity by the price, the cost price. Now, why are we sourcing the sales table when we can actually use the products table? And that is because the cost of goods sold is going to be determined by the number of sales that we make, and the data for sales is going to be come from the sales table, which is why we are sourcing the quantity from the sales table and we are sourcing the cost price from the products table. So if I do this calculation and check the amount, so let's see what we've got here. It is 19,000. Let me change the callout value, display next to none, change the formatting, and let's just verify if our calculations are correct or not. So let's go to the sales table, and we already have a cost price column that we have calculated in our previous videos. So all we need to do is create a new column, and we will call it COGS is equal to my cost price multiplied by quantity, and this gives me the COGS column. Now if I pull the COGS column here on the canvas, convert it into a card, change the formatting, and yeah, we have verified that what we have calculated using our measure is actually correct. So yeah, that brings us to the end of the fifth part of this video series. I hope you enjoyed watching this video and found some value from it. If you did, please share it with your friends and let me know your feedback and thoughts in the comments. And until then, I see you in the next video, and happy learning and thanks for watching.